Well, we can have a look at the final problem. The letters A, B, C, D are placed into this grid as shown. For a fewer of the empty 1 by 1 square are shaded in, so that each lettered square shares a side with exact one shaded square, and no shaded square shares a side with another shaded square. So each letter is covered, or let's say has got exactly one neighbor, and the neighbors are not neighbors, I mean, between themselves, right? No shaded squares shares a side with another shaded square, right? So let's just give a proper study of those examples. So basically the question is, how many different ways can you make such an arrangement given given these restrictions? This is good. A is covered by this guy, and C is covered by the same guy. I mean, this guy is shared. This guy is like used twice, but it is allowed. B is covered by the guy on top, and C is covered by the guy on the side. And these three boxes, we don't use four. We can use for fewer, up to four. Three will do the job here. And the three boxes, shaded boxes, are not attached, so everything looks good. This one is also okay, and A is covered, B is covered here, C is covered by the one on the side, D is covered by the one on the side. So we have got one more quota. Actually, we've got one more box to put if you want. I mean, if you want to use four. So the fourth one can probably show up here. It's neighboring to no one, and it's not covering any letter. So there's no like multiple covering. This is okay. So this is not okay. There's multiple covering. D is covered by two guys. This is not allowed. And this is not allowed because A is not covered at all. It's unattended. This is not considered covering. Covering is like sharing a one side, one common side. And this one is not sharing any common side with A. So A is not covered. This is not okay either. This one is not okay because these two shaded boxes are next to each other. So neighbors cannot be neighbors themselves, right? Otherwise, I mean, you can move this probably over to here, then it would be good. A and C are both covered. B is covered and D is covered. Yeah. So this attaching thing is the only problem. Yeah, that's it. And how many different ways are there? Well, I think we're gonna start from this thing, right? We can use up to four. We can use, of course, you're not going to use zero. You can use one. If you just use one box, you can at most cover two. You put this one in the middle. This is the best you can do. And for the rest, you need at least one more box to cover them. So one box is not enough. You start with two or three and then four. I guess this is the broad categories. So you can use like two, you can shade two boxes. You can shade three boxes. You can shade four boxes. Right, three different cases here. And if you shade two boxes, you literally need to do the one here between AB and the one between CD, right? This is the one way, or the one between AC and the one between BD. I mean, you just turn that by 90 degrees. That's the only two things you can do. Because you use two boxes to cover four, so each will take care of two. So that's the only two ways, I think. Yeah, that's it. So for this case, it would be like two ways. Okay, this is pretty straightforward. And now we consider three boxes. Okay, when it comes to three boxes, probably need this picture. Why don't we just copy? I'll draw it anyways. Three boxes. So one of them is shared. The other two, I don't know. No, one of them is shared because you've got four. You've got three instead of four. So one of them must be shared. Let's say this one's shared. How about the other one? There are two cases, right? The other one is not shared. If the other one is not shared, what's gonna happen? You're gonna choose you're gonna choose from these two places for C, not this place because it is shared. Okay, so I said there's no sharing, and this is already forbidden because B is already covered. So for C you're gonna choose from these two corners, and for D you're gonna choose from these two corners. That is to say you've got 2 times 2, that is 4 cases. If you assume this is the shared box, that's 4, and then this one can rotate, turn around. So there are like 4 different places for this shared box. So it is in total 4 times 4, that is 16, of 16 of them, 16 ways. Okay, that is to say the one is shared, the other two are not shared. So this is like 16 ways. However, that's yeah, I put 16 here, and I'm gonna erase something over here. Erase it. And you can also do this. This is shared, the other is also shared. Okay, and now you've got one more because you've got 3 boxes to put, right? These two are fixed here. Later you're gonna turn that by 90 degrees, but for now let's say we consider this case. These 2 boxes are shaded, so everything's covered. Then you're gonna put the 3rd box somewhere safe. So where are safe? I'm gonna use a different color. This is not safe because A is already covered. You can't put something here to cover it once more. For the same reason, these are not safe. And since shaded boxes, these are not safe either. And since shaded boxes cannot be next to each other, so this one cannot be shaded. So does this one and this one. So we've got 1, 2. This is safe, right, in a corner. This is safe. So 1, 2, 3, 4, 5, 6. That's 6 of them. And then you can turn the whole thing by 90 degrees. So another 6, that is 12. So you've got 12 here. So in total, that is 28 ways. Why don't I just write 28? Right, okay, so far so okay. And this final case probably is the dirtiest case, but we're gonna go through it anyways. So use 4 boxes. You can choose to, let them all be useful. That is to say, you cover each one is covering one, or probably you're gonna use only 2 to cover everything and waste to sort of put the other 2 at some safe corners. That's probably also doable, but let's just look at it. So basically, how many boxes are shared? Probably 1 box is shared. I mean, only for this case. Okay, 1 box, no box is shared. 1 box is shared, and 2 boxes are shared. If 2 boxes are shared, that's kept there because 2 shared would cost 4 to be covered. You don't have 3 shared; it doesn't make sense, right? So that's it. If 0 is shared, that is to say this is A, B, C, D, right? So every one of them is gonna be in a like corner. You choose one from these 2, and you choose one from these 2, and so on and so forth. So that would be 2 to the power of 4. That is 16 different ways. Okay, and then if 1 is shared, let's say if this one is shared, the other 2 are not shared. So the other 2 are going to be like you choose 1 from these 2 and choose 1 from these 2. And this would and then after these 2 are chosen, you're gonna look at the whole picture and see how many spots are left safe, right? And this would give you like 3 more sub cases to discuss. So yeah, this is a bit nasty. This is the like level 1 case, this is a level 2 case, and now we've got level 3 cases. That is to say, if you're gonna choose 1 from these 2 and 1 from these 2. So basically 3 cases. It is either side. By side I mean this one and this one, okay, or maybe side down. Side down is like side down, okay, or maybe downside. But these 2 are actually symmetrical. and finally it's down and down. Okay, let's do them one by one. If you do side and side, you have this and this, right? And now let's try to cross off all unsafe spots. Okay, these are not okay because you can't, so far everything is covered, you can't cover them once more. This is not safe, between here is not safe, this is not safe, this is not safe because unshaded boxes cannot be neighboring to each other. This is not safe because you can't cover A and B twice. This is safe in the corner, this is safe, this is also safe, so 3, okay. So for side, that's a 3 of them. And yeah, later we're gonna do times 4. Let's assume like this is the shared box, just one in a one shared scenario. Later everything is going to be multiplied by 4. Here, yeah, that's it. And it's now side down. I definitely need a new graph, but let me do it. A, B, C, D, and now we are doing side down. Later downside will be, so let's say side and down, okay, and this is the fixed shared box. Okay, now let's mark off all those unsafe spots. Not safe. This is not safe either. This is this safe? Yeah, this is a safe. This is also safe. This is also safe. Yeah, so we've got 3 like safe spots. This is also 3, and for this one should also be 3 because of a symmetry. And finally it is down. Eraser. I'm not sure if this is a great problem, but it's a lot of casework. Just gonna be careful. You don't miss anything. You're gonna discuss them case by case, right? So this is down. So this again is the shared fixed box, and then you've got down here. So let's mark off or unsafe spots. Not safe, not. That's a lot. And now this is a safe. This is safe. So 4. Okay. 4. Sorry, different color. That's 4. So in total, that would be 9, 4, 13, right? And then this is to say this is fixed. This is the shared, the only shared box. So in total, it's this thing multiplied by 4. That is 52 different ways. Okay, this is to say you have 1 box shared and you use a total of 4 boxes. Yeah, and then 2 shared. That is to say you've got more freedom. But let me erase something first. Yeah, now that's it. The thing. You got 2 shared boxes. B, C, D. Okay, let's say this direction later is going to be multiplied by 2. Okay. So these 2 are shared boxes and everything is now covered. So we got 2 more boxes to deploy, and we are going to see where are the I mean, where the safe spots are. So these are not safe anymore. You can't put them here. Right? And then this is safe. This is also safe. Safe. Okay, so on the corner safe. So there are a total 6 boxes, and you're gonna choose 2 out of 6. So that is choose 2, 6 choose 2. That gives you basically 15, and then you can turn this by 90 degrees. You can shade the one between AD and the one between BC. You got another 15, so it is like 15 plus 15, that is 30 ways, right? This is to say if you use 4 boxes, then you have 3 sub cases. This is especially dirty because this one goes down to 3 sub cases, second order cases, so to speak. But anyways, we are done. So we add them all up. That is 68, 30. That is 98. So this is 98 different ways. And then you add them all together. That is 30, 98. That is 128 different ways in total. Okay, you can choose to use 2 boxes, 3 boxes, or 4 boxes. But there's no way that you use just 1 box. Otherwise, you won't be able to cover everything. So yeah, 128. Do we have this option actually? Oh yeah, the last one, E. So yeah, E should be the answer to this problem. This is not actually a hard problem. And assuming that you did stuff fast enough, and then you have probably 10 minutes, let's say 15 minutes on this problem. You give it a proper analysis, and it should, I guess you're not too far. You won't be too far from this kind of a broad cases, and then you notice that there are sub cases. Yeah, it takes a bit care, but it is not too hard. I mean, it is unlikely that you miss something, because given that you go by these numbers, you need to convince yourself why, like, let's say 3 is not okay here, or why shouldn't we start with the 1 and something. Once you are okay with the boundaries, then you are confident. The rest is just crossing out those bad spots and account for on the valid ones. I think that is it for Gauss Grade 7. In general, it's not an easy paper, especially when you compare this to Grade 8 this year. I would say Grade 8 paper is even easier than this. This one is a bit confusing, like 24 and 25 is time consuming. This algorithm thing is definitely confusing. This thing actually has to do with linear programming. It is not as straightforward. Probably this is the hardest problem on this paper, mathematically. From a mathematical perspective. Yeah, everything else should be fine. Yeah, this is a fun problem. This is a fun problem. This is also not a bad problem. Actually, this is not a bad problem. Yeah. I think that is it. Okay, so I'll record a few more videos on discussing Grade 8 problems and see you there.